Welcome, students, to this explainer on software standards. If you're prepping for your exams, well, you're going to want to pay close attention today. Why? Because this section, from Chapter 24, is the absolute essential foundation of plan-based quality management. You see, it's fairly easy to write a computer program on your own in your bedroom, right? But professional software engineering, that requires us to build complex, highly reliable systems in large teams. And to pull that off successfully, we absolutely need standards.
Okay, let's dive into this and map out the exact chronological flow we'll follow from the textbook today. We're going to cover 1. The value of standards, 2. Product versus process standards, 3. Overcoming developer resistance, 4. The ISO 9001 framework, 5. The ISO 9001 reality, and finally, 6. The lecture summary and next steps.
Let's jump right into Section 1, the value of standards.
Now, it might seem obvious, but before a management team can actually enforce quality across a project, they have to first define what quality really means in their specific context. And that's exactly what software standards do. They are the foundational framework in plan-based quality management that encapsulates best practices and establishes an objective baseline for assessing software quality. Think about it like this. In traditional manufacturing, you can measure a physical part to see if it fits the blueprint. But software? Software is abstract. It's completely intangible. We don't have those physical constraints, so we use standards to create a clear, measurable baseline. That way, everybody on the team knows exactly what's expected of them.
There are 3 critical reasons why these standards matter so much in the real world. First, they capture hard-won organizational wisdom. Look, when a company makes a massive, costly mistake, they learn from it. Standards basically bottle up that knowledge to stop the team from repeating the exact same failures down the line. Second, they define an objective baseline for quality. Quality can be super subjective, right? What looks like elegant code to one engineer might look like a total mess to another. Standards completely remove that guesswork. And third, they assist continuity. Software has a really long lifespan. If a developer leaves your company tomorrow, the next person to take their desk has to be able to step in and easily read their program code. Standards ensure all engineers adopt the exact same practices, which drastically shrinks the learning curve for new team members.
So, quick micro recap on the value of standards. They are incredibly valuable because they prevent repeated mistakes, they define quality objectively rather than subjectively, and they guarantee project continuity across different developers.
Moving right along to Section 2, product versus process standards.
Now, definitely highlight this in your notes, because this is a crucial concept for your exams. Software engineering defines 2 distinct but related types of standards, and you really need to be able to contrast them. First, we have product standards. These apply to the actual software product itself, the tangible thing being built. On the flip side, we have process standards. These define the processes that should be followed during development, the how that thing is built. Basically, one governs the final deliverable, while the other governs the development behavior and methodology.
Let's break down some practical examples to really cement this theory. Let's think about product standards first. A Java programming style guide, a specific format for a method header comment, or the exact structure required for a requirements document. These are all product standards because they dictate the shape of the actual output. Now think about process standards, the conduct required during a design review, the steps you have to take when submitting new code for a system build, or the official version release process. These all dictate the workflow. So in short, a product standard tells you what the code must look like, and a process standard tells you the steps to take to get that code approved.
Just to briefly recap that before we move forward, product standards are for the tangible outputs like your code and documents, while process standards govern the workflows, the actions, and the procedures of your engineering team.
All right, Section 3, overcoming developer resistance.
We need to acknowledge a very real, very human conflict that happens in the industry all the time. Introducing strict standards to a team of engineers is, well, almost never met with applause. So I'll pose this direct question to you. Why do software engineers often hate standards? The reality is, a lot of developers view standards as tedious, bureaucratic paperwork. They often feel that rigid rules stifle their creativity and box them in. They want to focus on solving really complex technical problems, not filling out forms or obsessing over formatting rules.
Now, what's really interesting is how standard management principles can actually solve this human problem. First off, managers have to involve software engineers in selecting the product standards. If developers understand the why behind a standard, they are way more likely to actually commit to it. Second, you have to review and modify standards regularly. Technology changes at lightning speed. A standard from 5 years ago might be completely obsolete today. But the third point is by far the most crucial. Automate compliance with software tools. If a tool can automatically format a program's layout to meet the Java style guide, the developer doesn't have to waste time doing it manually. It's simple to minimize resistance, minimize the tedious manual labor.
So, wrapping up developer resistance, if you want to get engineers on board, you've got to involve them in the decisions, keep the standards modern, and heavily prioritize automation to cut down on manual checking.
Next up, Section 4, the ISO 9001 Framework.
We are now going to elevate our scope from internal company rules up to the global stage. Let's define the ISO 9001 framework carefully. This is an international set of standards that applies to a huge range of organizations, from manufacturing plants to service industries. And specifically, it applies to organizations that design, develop, and maintain products, which absolutely includes software. What it does is require a company to define their general quality principles and meticulously document their processes in something known as an organizational quality manual.
Now, a really common misconception you should avoid here is thinking that ISO 9001 is some sort of rulebook that teaches you how to write good code. It's absolutely not. ISO 9001 is a framework for developing standards, not a specific list of software rules. It doesn't tell you what programming language to use, and it doesn't tell you how to design your architecture. Instead, it essentially demands that a company document its own processes in its quality manual and then mathematically prove that the company is actually following its own documented procedures.
To quickly recap the ISO 9001 framework, just remember that it is an international framework for creating and documenting your own internal standards via a quality manual. It is not some global programming guide.
Moving on to Section 5, the ISO 9001 Reality.
This brings us to a really critical reality check presented in your textbook regarding what ISO 9001 certification actually means in practice for the software industry. You'll find that many customers demand ISO 9001 certification because they assume it automatically guarantees brilliant software. It does not. Certification only guarantees that an organization has quality management procedures in place and that they follow them. What does that mean? Well, it means a company could, theoretically, write a completely terrible, highly inefficient procedure, follow it flawlessly, maintain all their records, and achieve full ISO 9001 certification. They could do all of that while completely ignoring whether the final software product actually behaves well for the end user. Because in this context, quality is defined purely as conformance to standards, not as user satisfaction.
So, our micro recap for this reality check. ISO 9001 certification focuses entirely on procedural conformance. It proves you follow your own rules, but it does not inherently guarantee the actual quality or usability of the final software product. Finally, Section 6, Lecture Summary and Next Steps.
We're in the final phase of our explainer now, so let's consolidate everything you've learned for your upcoming tests. Here are the absolute high-yield concepts you need to memorize. First, standards are the baseline for plan-based quality management. They capture organizational wisdom and ensure project continuity. Second, know the difference. Product standards apply to the thing being built, while process standards apply to the how it is built. Third, to overcome developer resistance, involve the team and heavily prioritize automated tools to minimize the tedious work. And finally, recognize that ISO 9001 is simply a framework for creating standards and documenting processes. It is not a magical guarantee of high-quality software. And that perfectly sets up our next topic in the course, Section 24.3, which covers reviews and inspections. Because, think about it, once we've established our standards, we need rigorous methods to actually inspect the software and the documentation to make sure those standards were faithfully followed by the engineering team.
But I want to leave you with a provocative thought as we wrap up today. If a company can perfectly follow a documented standard, achieve international certification, and yet still produce software that users completely hate, what truly defines high-quality software? It kind of forces us to ponder the limits of bureaucracy, doesn't it? And it points us toward the deeply human elements of software engineering, which we will continue to explore in our next explainer. Thank you for your focus today, students, and I will see you in the next session.